right, we're going to get started. This is tests are what you want, what you really, really want. We want to engage with the community about tests, and the goal of our session is to share ideas, talk with you guys about tests, different way you test, kind of have it in a lively discussion about different topics. We don't have a ton of slides. The whole idea here is for people in the room to help bring topics and talk about different things that they care about with tests, share their opinions, and have different discussions about various things. So I'll go through, Daniel and I will go through a few of these topics to kind of get the discussion going. But the whole idea is to get everyone involved. So intro to this, tests. Like what's the goal here with a test? I mean, we put a few simple ones that hopefully everyone would agree with. And if you're going to write a test, it has to test something. That seems pretty useful. Has a finite runtime, right? We don't want our tests running forever. They're cost efficient, right? We're not going to run up the bill just over a test. The developer friendly, right? We can understand them, we can engage and talk about them. We know what they mean, after they run successfully or unsuccessfully. They're developer friendly. It's easy to write, easy to read, easy to communicate about, and have a deterministic outcome. We know that this thing is going to run to completion and that it will have some outcome, whatever it is, and that's something that we can understand. Okay, so that's high level what we think we should care about with tests. Okay, so we're from the KubeVirt community. So one of the things that we wanted to talk about is kind of like what are the pain points we experience? Like what some of the things that we come across in KubeVirt when we were thinking of tests and how different ways that we could improve on tests. One of the things we see a lot of is pictured here. Like we'll run tests and maybe they don't work exactly the way that we hoped. So what do? We just hit the retest button, right? Probably everyone has done this in some form. This is usually what we do, and for our tests, we just hope that they're eventually going to work, right? So obviously we have to have some memes. Yeah, it didn't work, so let's just do it again. Let's just keep retesting, right? We're not gonna. Maybe the test is fine. Yeah, some more of this, over and over and over and over again. We just want to hit retest. But anyway, this is one example of what we do and have experience in KubeVirt. I'm sure people have some other examples and things that they do. But anyway, we thought that was funny. So. All right, to reiterate the goals. So we want to learn something. We want to share ideas with everyone in the room. We obviously don't want to just run and retest everything. Like there's better techniques out there. Obviously, there's probably better ways we can write our tests. Okay, so here are our topics, our high-level topics that we want to discuss with everyone. Tooling, reporting, dealing with flaky tests, scale performance tests with CRDs using simulation with Quark and QMark. So we're just going to go through the topics. Please come up to the microphone, shout out things that you want to talk about or care about. If you want to have an opinion, just share it. And if we don't have anything, we'll just share about things we do in KubeVirt, and we'll hopefully use up as much time as we can, but hopefully you guys can add some more to it. Okay, go ahead. Tooling.
Okay, I need to take a quick look because I always forget what I need to talk about. So, hey, my name is Daniel Liller. I'm in charge of CI of the KubeVirt project. And our tests are largely running on Ginkgo and Gomega. I figure that many of you are probably familiar with those. We are running our own Prow instance, so that's where all our test lanes are running. And what I also want to talk about today is like a Kinnear approach. I figure that most of you haven't heard about that. That's like an approach where you try to cut down on the rerun of flaky tests.
Does everyone here use Ginkgo and Gomega and Prow? Everybody?
No Prow.
Okay.
No Prow.
Does anyone want to share something that something else that they use to get like, to accomplish these goals? Do you use like Jenkins? Like what are you using? Tecton? Okay. What do you do for like equivalents? Like, when you're doing your testing, you use Ginkgo, Gomega? Yeah, you do? Okay. So Tecton, we've got one outlier with Tecton. Most people Prow. Anyone else? Like what other?
Testify, Go CNP.
Okay. Testify, Go.
Testify, Google's.
Okay. Okay. Testify. I haven't heard of that one. Okay. Cool. Any others? I'm sorry? Jenkins? Yeah. Okay. So all right. We got a few tools out there. Does anyone, for equivalents, do people use, I don't know, like what else is there other than Ginkgo and Gomega that people use for Go? Is there any?
So that's Testify, for example.
Testify will always be that? Okay.
Just the standard library.
Okay. So that's another one we could do. Okay. Does anyone want to talk about these? Like any opinions about these? Like one better than another? I'm not familiar with some of these. Like what did you not like about Prow or did like about Prow? Does anyone want to share? Go ahead if you want to grab the mic, yeah.
Okay, can you hear me?
Yep.
So basically right now, I think even the Go official recommendations from the Go team say that you should basically embrace the Go standard library and do not use the assertion libraries because, for example, Go, if I remember correctly, Ginkgo and Gomega basically is coming from RSpec, I think, basically kind of structure. So basically it just has like it uses like I would say idioms from other languages which are not really coming from Go. And if you look, for example, at the implementation of the Go standard library, they're structured completely differently. And it makes very difficult to grasp and learn how, especially Ginkgo, because Ginkgo is like the framework, right? And Gomega is more for assertions. So these assertion libraries work differently. They're structured differently. The parallelism work differently. The way how you verify work differently. If you want example, I do not remember if Gomega, for example, has this possibility to stop the test if your assertion fails or just continue further, which is idiomatic in Go that usually you try to assert as many things as possible in one test. So you keep going until you get all the things. So I think that currently there's a preference in Go just to use the standard library if possible.
Okay.
Yeah.
So this is with Testify? This is
Testify is not
okay.
really also recommended because Testify is just an assertion library. So
okay.
we just have assert, for example, equal, assert, like greater, and there's a separate package called require. So require basically does this fatal if or fail now, so it just breaks. So it's just two packages. One tells you that it should, stop and fail. This is require, and assert just go further.
Cool.
So,
okay.
yeah.
Thanks for sharing.
Thank you.
Okay. Cool. I haven't heard of that. That's cool. Okay. All right. Well, why don't we go to the third one since you want to talk about flaky tests and the tools there.
Yeah. So, so where can I start? So you saw like the picture beforehand, like with this is like ridiculous amount of retest commands, probably. That's based on that we had a pretty hard problem of flaky tests. And so we've been looking at trying to reduce those and also like to cut down on those because like this is waste of CI resources, right? So what I stumbled over was like a paper by someone who's called Gregory Kapfhammer. I don't know if I pronounce the name correctly, but that's not really important, I think. It's like he described there like an approach where you could like determine whether a test is either flaky or not flaky or in between. And for us, the only subset to rerun that makes sense is to run the test in between, like where you're not sure whether it's flaky or not. So just as a background, I'm not sure if I have like a picture of that. No, I don't. So, okay. So the thing is like the majority of our E2E tests, we have a pretty big E2E test suite, which is like I would say 1,500 tests or something. Or do you have like a?
I don't know off the top of my head.
You don't know? I don't know either. But yeah, beyond like 1,000 tests that are being run, we have like 35 test lanes that are running on every PR. So you might imagine that there is like a lot of E2E tests going. And yeah, whenever you have a flaky test, that ruins your whole experience. Like on the one hand, from the developer itself, that is like not understanding whether this test is failing by his own input, or whether that test is somehow failing by some external thing that he doesn't have any influence on, right? So that's what we want to fix with that. So this approach actually does, I think I did say that, does put like a set of feature vectors from the test that is under surveillance. It estimates like a set of like static runtime analysis and static analysis and runtime properties, puts all that into a feature vector and feeds that into a randomized random forest model, and then you can get a prediction out of that whether in what category that test belongs. So that's basically what we are trying to do. So just as a quick description of that, I've just put up this list of features that are actually like part of the paper. I'm not sure if we can implement everything right away, but like the probably relatively easy things like cyclomatic complexity and things which are like just static runtime analysis, we can program. So the use cases for that are pretty much. There is many use cases. Like, first of all, obviously we want to like detect flaky tests before the merge, before it enters the code base and a flaky test comes into that. The other thing is like we want also like on the stable code base we want to run the tests that have been changed to see whether they are flaky somehow or not. And also what you could also imagine by the feature set that you see here, this could be pretty good advice for the test engineers that are actually rewriting the tests. Whether, for example, like the cyclomatic complexity is like beyond like someone else being able to understand what is going on there. So all this is planned things. We are going there, and if you want to join in, there is the implementation PR that is still under development. But yeah, if you're interested, just take a look at that. So anyone else working on something similar? Okay.
Yeah.
You never know whenever a test has been fixed or not, because like a flaky test doesn't care about how often you run it, right? So it could be even flaky after 10,000 times. You could run it 10,000 times, and on the next run it might be flaky. So you never know when you have fixed it. But we try to just I most of the time like talk about our job. What we are doing is like extinguishing the fire somehow. So concentrating on those things that are hurting us the most, that are wasting the most resources. So that's what we're trying to do. So we have reports, which I'll come to later, so that we can have something like a heat map or something where the real hurting is going on. So yeah. Does that answer your question? Okay, thanks. Anyone else? So any other questions on so far?
Does anyone use any other techniques for detecting flakes or failures or something? Anything people want to share about in that area? Nothing smart. Interesting. Okay. Okay, so to summarize, like we get metrics, we look at the biggest, most important red flashing thing, and then we go and fix it. Yeah, okay.
Yeah, that's pretty similar to what we also do.
Yeah, no, that's interesting. Yeah, I think that's kind of like the idea that like Daniel's getting to, trying to explore, is that like trying to get, I think like you said, like can we make it smarter? Can we make it like, how do we avoid getting to the big flashy test that's flashing red? Like how can we avoid getting to the point of that it's flaking like that and causing us an issue? Okay. Cool. All right, I guess we can
Okay.
move on then.
So let me see. Yeah, so I just wanted to remind everyone whether you have like, if you have Prow, you can just leverage test grid, which is something that might be pretty easy to configure. Does anyone know test grid? You know, obviously, yeah. Sure. Anyone else? You know also, yeah. A couple of people, okay. Then I don't want to spoil. Okay. So, okay, we have like a very simple tool that just gives us like an overview over all the runs of our CI infrastructure taken from the Prow. We are just scanning all the PR runs and trying to make sense of the data. And what we are doing is actually like having some kind of grid where on the upper part you can see the project name, on the side you can see the test name. And what was most useful for us, similar to as what you described, was which test is failing the most. That should be on the top of the list, right? And that's actually what we have this simple tool for. I mean, it will not deserve like a design prize or something probably, but yeah, it does the job. So what is also helpful out of that, it gives us a first resort, and it gives us like an output JSON, which we can then reiterate on to have like a second thing. Yeah, okay. The rest you have already seen. So this is like the heat map that it gives us. So we are looking over the tests of the last 2 weeks, and then looking at from 2 different angles. First of all, we are looking at failures per day, and then we're also looking at failures per lane. So that's actually where you see like where the worst action is going on. On the lower side, you also can see that there is like a top most recent flaky test, which is somehow like a condensed report of the previous one. But yeah, in the end, always what you need to do is to drill down on the test results and then look at the direct things to determine normally whether it's an infrastructure flake or whether it's a real flake that you need to. You always need to handle that somehow. You also have to make your infrastructure as resilient as you can. By the way, for example, if some like image repository is going down, it will not help you. You will still have failing tests. So you have to be like resilient on that part. Speaking of resiliency, who else had all these problems and how did you tackle those? So like resilience of your continuous integration infrastructure? Come on, guys. You all have those problems, right?
I can just say we deal with the same thing with the rest of our list. So we run all our CI infrastructure in Kubernetes along with other workloads, as well as the workloads and stuff. So we have on-call, we have alerts, we have normal monitoring. So when things go wrong, the person assigned to that feature or whatever gets changed to deal with it. Hopefully we have learned from it and get self-healing stuff implemented.
What do you use to report the results? Use like Prometheus? How do you are you using? You do, okay.
Yeah. So the basic Kubernetes stuff is all exposed to in-air in our case.
Okay.
Alert manager changes out when needed.
Okay. And you probably have dashboards like use Grafana or something.
Yes.
Okay. And that's how you get the flashing red lights from the. Okay. Got it.
Because we use TechTarget, which is like Kubernetes native CI building blocks, it is all just Kubernetes. Kubernetes, this thing is.
Interesting. Okay.
Yeah, I mean, with Tecton you get a lot more, right? Like being able to structure your pipelines. So, for example, when like the compile fails, there is no use of running the tests anyhow, right? Yeah, that makes total sense.
Yeah, each step becomes a pod. Each task becomes a pod. And each step is a container within the pod. It's all just.
And you also have like the benefit of promoting artifacts, right? Like similar to Jenkins, I think.
Yeah. It's basically a building block toolkit. So you can do a support file, things like that.
Yeah, makes sense. Yeah. Okay, anyone else?
That sounds like flake harm reduction.
We've introduced a lot of flakes to this as well.
Okay. Yeah, I think we can move on. Okay. Next, scale and performance tests. Kind of consider this to be like I've got my MVP, I've rolled it out, maybe I've reached production, maybe I've been entering production for a little bit. Like kind of an advanced thing. Like I think something that always doesn't get enough love. And I think this topic is, I think it's also can be particularly complex. There's a lot of tooling and different techniques around this one. But I mean, maybe, so let me ask, like, how many people have or do scale and performance tests for their CRDs? Has anyone ever done that? Yes, I got somebody. Tell me, what you have, so you have your, you got your own CRD, you've written your own scale and performance tests.
So we actually,
Do you want to take the mic, please? Thank you.
Yeah, so practically we run an internal platform team, so we do scale tests for both our internal CRDs and anything we brought from the open source. And the main reason for that is simply, again, because it's CD and you can fill up at CD, and that's a total cluster outage. I think it's imperative that if you run beyond several thousand nodes or several tens of thousands of pods, you kind of need to. Yeah, so we use something like usually cluster loader, kubemark. Methodologies do differ, but we basically try to see again how fast can the controllers keep up. What is the percentiles of reconciliation times of each controller looks like? What is the etcd various metrics look like while we're conducting the stress test? How fast are we able to load the cluster? Like, is the loading strategy as good as is good, basically good for finding the bottlenecks. So those are basically what we look at.
Cool. Okay. Thanks for sharing. Yeah, you nailed one of the points here that we want to specifically drill into. It's like with etcd, right? It's a shared resource. Your CRD is going to use etcd, but it's also going to use the API server, right? So when you do your REST calls, like you're going to use the API server. So are you being responsible? Like, are you just hammering the API server with list requests, right, with your CRD? Or do you have tools that are doing that? Are you just, are you patching constantly? Like, are you measuring that? And are you measuring how much memory the API server is using when you do this, right? So these are complex topics that I think, so there's some tooling around this, and let's talk about, so we're going to talk about the KubeVirt example. So we went through this exercise in KubeVirt. So obviously KubeVirt is a CRD, and it has REST calls that are made to the API server. So what we should do is we should figure out how many it's making and what is normal. Like, what is like the expectation so that we can, as we work on KubeVirt, we're not like increasing this to some unmanageable amount, right? Like we have, if we're going to introduce this patch, we probably want to figure out if this thing is going to have a loop in there that's just going to patch something, right? It's going to affect etcd, it's going to affect the API server. We need to know this stuff. And then our performance measurements, like, can we estimate, like, when we do this stuff, like how well everything's going to perform, how much memory it's going to use, et cetera. And then our final goal was that we should be able to publish this every time we release our CRD. Every time KubeVirt releases, we should be able to tell everyone in the community to say, here's all the number of REST calls, here's how much memory we expect to use, here's a rough estimate how much we think it'll scale. Yes, question?
I have a question, I hope it's not dumb. Where are you running those scale and performance tests? Because I think you're a CNCF project, so I guess you're not running them in GitHub Actions, right? Or you do?
No, as we said, we are using Prow, and this is just one of the Prow lanes that we have. Does it answer your question already, or do you have more questions?
Probably need to do my homework.
Yeah, so this is one of our test lanes that we introduced probably, I don't know, I think it might have been a year. I have the date here. About a little over a year ago. This is an example, actually. So we published this, and so the things that I want to highlight here is that you see we obviously see a lot of dots. Those are the tests, and then we grab a numerical value, and that's how we plot that number. we have an orange line that's horizontal across the stream. That's just what the average is. And then we have these vertical dotted lines, since those are going to be Kubernetes releases. So we're going to do different releases of KubeVirt, and then Kubernetes is going to release. And then we have like this matrix of things that could affect KubeVirt, right? Performance and scale, like the number of requests we're making. So this specific example is the number of patch requests that are made for a VMI. So the control plane is going to patch a VMI, like it's going to maybe change the label or something, and it's going to make a patch request for a pod. So it's going to be move a label from a VMI to a pod, and that request is going to go to the API server. So we measure these things. So specifically, this test we do per 100 VMIs, which is 100 pods. So like roughly the line is around 200. So that would be like 2 to 1. So for every pod that KubeVirt is interacting with, it'll make 2 patch requests. And so we can measure this, and we measure it over time. We can see that like around 2024, this changed. This changed from 200 to 400. So somewhere in there, we added another patch request to a pod. And so we can see this now, and this obviously has implications, like I said, for scale. This has a memory value associated with it. I mean, it's really hard to say exactly what that is, but we know that every one of these things will eventually, at enough scale, cost memory. So we want to be cognizant and aware of these things. So this will tell us that the new KubeVirt release, you will get 4 patch requests when you create a pod. So we can measure these things over time, and this is really useful for us to measure. And we wrote a bunch of tools that do this. They're in the KubeVirt repo. Pretty simple. Like I said, it just creates 100 objects, and then we scrape Prometheus over the time period that we created these things. And there's a bunch of metrics that you can grab in there that'll tell you like all the REST calls, and then we tally them up and then publish them this way. Okay, so does anyone? Okay, so this is just an example, but I think so. In the interest of the reason to share this is because I think if you have the ability to do this, like with Prometheus, and you've got a test that currently exists that does performance, this is a really cool way to measure your CRD and measure it over time, and you can publish it just like this. Unfortunately, I don't have a link. I wish I did, but you can Slack me afterwards. I can give you a link to the tools that show how to do this, and which metrics they scrape. They're general metrics that Kubernetes publishes. Okay, simulation. The tooling that you can use for this. I heard one mentioned earlier. I heard KubeMark. And the other one would be Quack. And there might be others out there, but I think these are the 2 predominant tools that you'd use for actually doing these kinds of testing. KubeVirt is just starting to, so we have real hardware that we run that test I just showed on, where we'll start up 100 VMIs. But now we want to do much larger, right? We actually want to do like 100,000 or 10,000 or 50,000 or something, right? So how do we get there? Like, how do we start up 50,000 pods without it costing too much money? Quack is really useful. Quack is Kubernetes without KubeVirt, or Kubernetes without kubelet, excuse me. And it's a way that you can launch essentially you have virtual nodes, like this idea that you can have these objects exist, and they make all the API calls to Kubernetes as if they exist, but they're not real. They're not consuming resources. So we can just create tons and tons and tons of these things, stress the API server, stress the control plane, and measure how it performs. So this is one we're just starting to integrate with. I think there's some examples of it out there in the community. I don't know if anyone's seen these or has tried using Quack for scale testing. Has anyone? Yeah, okay. And then the other one, KubeMark, this is interesting. So because KubeVirt has its own control plane and almost kind of like a runtime to it, one of the things that we can't test is is like the VMI interaction. There's like a daemon that we have to run in a node that sort of manages the virtual machine resource. There's no way for us to test that, right? Because Quark is, there's no real runtime. So the idea is that we have to have like in KubeVirt a KubeMark-like test that will take create lots of these things, these daemons that were to manage our virtual machines, and we have to like simulate that whole thing. So kind of like how Kubernetes uses KubeMark to simulate nodes and to do like large scale, like 5,000 nodes. Like that's how Kubernetes test scale. It can do like 10,000 nodes with KubeMark. We basically would want to do the same thing. So slight nuance there that you can also test. That's a little bit different than Quark. Okay. Any other comments about simulation tools people are using, or any comments about these in particular? Okay. Okay. I don't know, how are we doing on time?
I think
We're at time? Okay, cool. All right, thank you everyone. Let us know if you have any questions. Find us afterwards.